Awesome. So our project is called Visual Search with Dynamic Participation and Fault Tolerance. And our motivation was that, let's say an Amber Alert is issued for a missing child. How do we solve the problem of finding this child quickly? And we thought of crowdsourcing in the sense that everyone has phones and everyone has photos that are taken on these phones. And maybe we can use image recognition to find whether the missing child is in these photos of all the phones that are in that area. So both of us are electrical and computing engineers, and our focus was on making a distributed system. So we actually took the image recognition library off the shelf, but we focused on two specific parts. One is dynamic participation, and the other one's fault tolerance. The dynamic participation is that people have phones, and people can upload pictures, the network can crash, they can leave anytime they really want to. But we really need to handle that case, because I feel like that's the most important thing in a system like this. And the second one is fault tolerance. And there's going to be millions, trillions of phones, and we need to handle faults in the sense that if the server crashes, if Cloudlets crash, if we somehow need to make sure there's backups and way of generating the system up and running again. And the final aspect was using Cloudlets. So we use Cloudlets because image uploading and sending images is a big task, and Cloudlets make this easier because they're located closer to the person sending these images. So we use Cloudlets to offload the task of image recognition and also make the compute as close to the phones as possible. So just to go through a workflow, how it would work is that there's a web app and a person's child is missing or someone is lost. They would enter the information, the name, the email ID, and a zip file consisting of all the pictures they know of this person. The coordinator then accepts the zip file and sends the job out to all possible Cloudlets in that region. The phones can connect to Cloudlets, so the phone gets an Amber Alert issued, and the phones say, okay, you can upload my images to the cloud. They say okay, and all these images get uploaded to the cloud. The cloud runs a basic face recognition algorithm and returns any matches. And the coordinator also takes care of load balancing in the sense that there's two aspects to it. First, we need to obviously assign phones to Cloudlets that are nearby the phones. And secondly, we need to assign Cloudlets that are low in compute right now, in the sense they do not have a lot of phones on them. So the coordinator takes care of the load balancing part of it. So actually, we can just start with the demo right now so that you guys can see how it works.
All right, so in the demo, this computer is going to be the server, so like what you see right here. It's going to be actually all of this. And then
It also has the coordinator replica running. This is
yes.
fault tolerance in the sense if the coordinator fails, the backup takes over. And we're using active replication with heartbeats to figure out when to take over, and any status change that happens in the coordinator is immediately pushed to the backups.
All right, and so these cloudlets here is going to be represented by this computer. So we're just going to be running one cloudlet for this demo. So the cloudlets also have sort of fault tolerance built in. So they also have heartbeats, configurable heartbeats to the server. So I'm going to set it for around 20 seconds just so we don't clutter my screen with tons of heartbeats. But so these heartbeats will be able to detect when the first server goes down and be able to fail over to the second server and continue like normal execution. And for the phones, so the phones will be done on shown on this laptop. So ideally, like this be an Android or iOS app, but for now we're just having like a GUI right here so that you guys can just see what the phones would look like on an actual application.
This is the front-end interface. It's like a website that basically that you can submit a job on. So right now I'm going to submit a job. Do you want to do your photo, Matt? Do you want to do your photo?
Sure.
Yeah, start it. Okay, so we're going to assume for this demo that Obama is lost, which is hopefully never happens, but it just did. And these are the pictures of Obama we're going to be sending. So these are the known pictures of Obama. We send it as a zip file, and I'm going to currently, actually, I can put any of your email IDs if you have access to it on your phone right now. Can I put your email ID? Awesome. So. Is that correct? PS Pillai at Android. Awesome. So I'm going to submit a job that consists of the images that I showed you. And it just tells you, thank you for submitting. We'll send an email if you find this person.
So I mean, if you look on here, it's kind of small, but we just received a job called Obama, which is the name of the job here. So the Cloudlet received the job, and then so these are just the two images on the phone that we are going to send over to the Cloudlets for processing. So you can see there's a picture of Obama here, and then a picture of Trump. So hopefully we get a match on Obama, and Trump just goes under the radar. So I'm gonna close this out.
Phone GUI can just accept.
Yeah. So this is what the phone like GUI looks like. It's pretty simple. So we can add an image. So we're gonna choose to add. Let me find these images. So those two images we had were in here.
So the phone
All right.
can upload as many images as it wants to be able to be searched.
Yeah. Yeah. So the phone. So now we selected two images. We're gonna send these over. So the phone just sent these over to the Cloudlet. We got a match, and we let the server know. So you should be getting an email sometime soon.
Yeah. So if you
Yeah, we did.
look at the phone, it should say
Yeah.
Face ID results, and it should send you a zip file consisting of, well, right now you can't open it.
Yeah.
But the zip file consists of all the matches, and
Yeah.
each match is named. Oh yeah, the zip file consists of all the matches, and each file is named the location where we found the person. So right now we just name it the city, but we can always configure it to have like the zip code or the latitude and longitude requirements. And
So right now we're just doing the city and the city and the state. So Pittsburgh, PA. But we actually grabbed the latitude and longitude, so we can get much more precise than that. We just didn't want. We figured for the demo it would make much more sense to just have something that you can understand rather than just the latitude and longitude numbers. So.
And if you see and just to demonstrate the fault tolerance part, if you see the secondary server continuously sends heartbeats to the primary, and it can detect if the primary is failed. So this is going to be an immediate failure. So what I'm going to do is I'm just going to crash the primary right now. And as soon as I do that, you can see that this says primary has failed, taking over as primary has failed, and now it's taking over as the primary server. That means that was immediate switchover with zero latency. So both the end user on both sides cannot tell if the servers ever failed. Currently, we're only working with one active and one backup. Sorry, one primary and one secondary. But you can make more replicas. We've configured that change. The only thing is that we need to run some kind of leader election algorithm to detect which the next primary is. But yeah, and then dynamic participation is just that he just closed the phone, and the phones can leave and enter this network at any time they want. So there's no load on the end user who's uploading the images.
Yeah. So the reason why we made the phones very lightweight because yes, they're going to be coming and going whenever they want, and I mean phones typically tend to have a lot less compute power than an actual computer or server. So it just makes it more lightweight, saves power, things like that. So most of the work, all the work is basically done on the Cloudlets. Yeah.
Awesome. Yeah, that's all. That's our demo.
Thank you.
Thank you.